Welcome user to the new lesson. In the previous session we have seen architecture of convolutional neural network. In this lesson we are going to apply CNN architecture
on MNIST.
dataset.
Fashion MNIST
Is a Zalando article image dataset that includes a training set of 60,000 samples and test set of 10,000 samples. Each sample is 28 by 28 grayscale image with a label from 1 to 10 categories. Right here we all can see 10 labels of dataset with their respective assigned value. Now let us make CNN model in the MATLAB. Under the selected directory, we all can see
MNIST
fashion dataset folder. This folder contained testing data. The dataset you can download from our website under the same lesson. If I open the folder, we can see subfolders having names 0 to 9. Each label or folder contained their respective images. Image data store object will store the data in the format of images. This function will take 3 arguments. The first argument will specify main folder name. Second argument will specify whether main folder has subfolders or not. And the last argument will tell from where MATLAB will take label name. Image input layer will feed image to a network. The height, width and number of color channels of an image determine image size. Sliding convolutional filters are applied to the input by a 2D convolutional layer. The convolutional layer is made up of a number of different components. 8 3 by 3 filters will be created for first convolutional layer. Same padding will add padding to the output so that it matches the size of the input. Each input channel is normalized over a mini batch by a batch normalization layer. After that, the ReLU layer applies a threshold operation to each input element. It will set any value less than 0 to 0. Downsampling is accomplished using max pooling layer, which divides the input into rectangular pooling sections and computes the maximum of each one. One or more fully connected layers come after the convolutional layers. All neurons in a fully connected layer connect to all the neurons in the previous layer. This layer combines all of the features learned by the previous layer across the image to identify larger patterns. After that, softmax function will calculate probability of each event to get final result. For classification problems, the final fully connected layer must be followed by softmax layer and then classification layer. Training options function will take various arguments. For this problem, we have used stochastic gradient descent with momentum. Different solvers works better for different problems. The adaptive moment estimation solver is often a good optimizer to try first. We can also try the root mean square propagation solver. The solvers update the parameters using a subset of the data in each step. We can specify the size of the mini batch by using the mini batch size argument. Each parameter will update in iterations. A full pass through the entire dataset is called an epoch. We can specify the maximum number of epochs to train by using max epochs argument. To gradually reduce the learn rate schedule piecewise name value pair argument is used. We have also specified learn rate drop factor and learn rate drop period. Training will happen by using function train network. This is how we can set the options for our network. Now if I run the code, MATLAB will take some time to show training window. Here we can see training window. We can observe how accuracy is increasing and loss is decreasing with respect to epochs. We can change argument values from training options and layers options to achieve maximum accuracy. In the right side of the window, we have seen training parameters that we have used to train the network. And this is a training summary. This is how we can carry out image classification problem in the MATLAB. This will end our video. In the next lesson, we will see what is data augmentation. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments and get in touch with us. Follow us on LinkedIn, Facebook and subscribe to our YouTube channel. Education is our future, MATLAB is our future. Happy MATLABing.